All right, we've got another area and volume free response problem. This time we have this curve here, polynomial, which is a quartic polynomial, f of x, and we have the horizontal line y equals 4. First thing they're asking us to do is to rotate this region R here over the horizontal line y equals -2, which is down here. I like to draw it just so I have a visual of big R and little r. Big R is the furthest part of the region all the way to the axis of revolution. In our case, that's going to be 6 because this is y equals 4 and this is -2, and so 4 minus -2 is 6. That's big R. Little r in this case is going to be the distance from the closer graph to the axis of revolution. So in this case, it's going to be x to the 4th minus 2.3 x cubed plus 4, and then we are going to subtract out this horizontal line of -2, and when we subtract out, we actually add. So we have big R and little r, and we are rotating, so we need basically pi times, and then limits of integration will be 0 to something, and then we need big R squared minus little r squared. Okay, and we'll have a dx there because it's around a horizontal axis of revolution. So let's go to our graphing calculator, and in the y equals, we're going to first plug in big R. So big R is 6, and then under y sub 4, I will plug in x to the 4th, x to the 4th minus 2.3 x, let me make sure that was cubed, yep, cubed, x cubed plus 6, oops, sorry, x cubed, and then down here plus 6. So now we're going to, oh, somehow I cleared that, sorry guys, x to the 4th minus 2, struggling here, guys. Sure that's never happened to you though, right? Okay, so x to the 4th minus 2.3 x cubed, and then plus 6. Okay, so now I'm going to go to my home screen, and I'm going to first put in my pi, then I'm going to do alpha f2 and do the integral section, or choice 4, 0, and then I need big R squared minus little r squared. So I'm going to have open a parenthesis and then vars y vars function y1, close the parenthesis and square it, minus open parenthesis vars y vars function and then y sub 4, close the parenthesis, square it. And I'm integrating with respect to x, and of course I can't do anything here until I know my upper limit of integration. So I should have done that to begin with. So let's go back to my graph. I'm going to go ahead and just graph this here. Oops, hit the graph button. There's my y equals 4. Looks like I have a standard window that's looking like it's fine. I need to know this intersection point right here. So I'm going to do second trace, choice 5, come over here towards the intersection point and hit enter 3 times. So my intersection point is where x equals 2.3. So that's going to be my upper limit of integration is at 2.3. So now come back to my home screen, and I need to go to the upper limit of integration and click on 2.3. And my answer is 98.867 or 868. So 98.867 or 868. All right, next problem. Region R is the base of a solid, and each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. So the area of an isosceles right triangle is 1/2 times the base squared. And the base is a leg. It's not the hypotenuse, so we're good there. And then we just need, effectively this curve minus this curve. So that's going to give us 4 and then minus the f of x curve. And of course, I'm going to integrate that from 0 to 2.3. And I'm going to go ahead back into my calculator. And what I need to do is go back to y sub 3 and, I'm sorry, not to y sub 3, y sub 1. I need that first curve to just be 4, okay? And then the last curve, I need to be x to the 4th minus 2.3 x cubed plus 4, because the original equations that I had put in were because I was revolving around this y equals -2 line. That's not in play anymore. So now I've got the correct equations. I go back to my home screen and I'm going to, don't need the pi, but I'll put a 0.5 out in front of my integral. We'll do alpha f2, choose the integral, integrate from 0 to 2.3. And then I'm going to need to insert paren and do vars, y-vars, function y1, which is the line y equals 4. Then I'm going to subtract out the function in line 4, which is y4, close my parentheses and square that difference. So I have the 1/2 out in front, and then I have top curve of 4 minus bottom curve of f of x, and square the difference. And then of course you need a dx at the end there. And when I hit enter, I will get, oops, looks like, what I forgot to do is put the dx in right there. So I just brought the equation back, put in the dx, and I'm getting an answer of 3.574. 3.574. Then last, I'm going to erase what I have over here so it's easier to draw and make it clear what I'm doing. But this next one says we've got a vertical line x equals k. It's going to split this into 2 regions. So the region here is going to be equal to the region here. We're writing but not solving the integral equation to solve for k. So we basically need the area of 4 minus f of x from 0 to k. K will be my upper limit of integration, equals the area from k to the intersection point between the curves of 2.3 of 4 minus f of x dx. And that is your entire setup.